2 starts from here. I'll take an example to explain you in detail between the fundamental and the derived units and how we can get the derived units using fundamental unit. So here I have taken length, area, and volume. Length is a fundamental quantity, and the unit for the length is meter, which is a fundamental unit. Now if I want to find the area is nothing but length into breadth, as you can see here. So the unit of the length is meter, and the unit of breadth will also be meter. So the unit for the area will be meter square. As you can see here, that this area is dependent on this fundamental quantity, which is length, and the units of area are dependent on the fundamental unit, which is meter. Now if we want to find the volume is equals to length into breadth into height, or volume can be written as area into height. In either case it will be meter into meter into meter, that is meter cube. So again you can see that the volume is a derived quantity which has been derived from the fundamental quantity, which is length, and the units of volume, which is meter cube, has been derived from the fundamental unit, which is meter. So the foremost point is to know about the fundamental quantities and their units so that we can get the derived quantities as well as the units through them. Let's study some derived units. Here you can see the list of some derived units. We have a derived quantity here, then we have the name of the derived unit. These are some special derived unit name given for the units for these physical quantities. Then we have the units in some other unit, and then we have the units in base unit. This is most important. When I'm saying base, I am talking about fundamental units, and we know we have 7 fundamental units that we have discussed in that previous video. Here we have taken few of them. We have taken kg for the mass, meter for the length, and time for the second, and then the ampere for the current. You can see that each and every derived unit is written in terms of the fundamental units only. Apart from writing in this base units, we can write them in some other units also for our convenience. Like you can see here that I have taken the units of energy and I've written in base units as kg meter square per second square. Now if I want to write in some other units, then I've written here Newton meter. Now Newton is kg meter per second square. So if we just substitute, we are just left with the Newton and meter. So we can write in terms of another units also. And of course there are some particular name given to the derived unit for those derived quantities. Let's see them. What are the special name of the derived unit given to some of the derived physical quantity? Here is a list of derived units with special name. Energy, the name of the unit is Joule and the symbol is J. The force is known by the name of the unit Newton. The pressure is known by Pascal. The power is known by the watt. Electric charge by Coulomb. Electric potential difference by volt. Electric resistance by ohm. Frequency by Hertz. Magnetic flux by Weber, and the capacitance by Farad. And these are the symbols associated with them. Instead of writing each and every derived quantity and its units in terms of base units or fundamental units, we can use these special names for those particular quantity, which is very easy to memorize and to understand and to write. So that was all about the derived units in this video. Thank you very much for watching this video. For more videos, you can visit our website transelearning.com. Have a great day.